Okay, good morning. So I think it's good to start the lesson now. If you remember, we talked about congruency of triangles, and I introduced you an axiom called side angle side for congruency of two triangles. And then using this, we were able to prove some theorems that actually they might seem obvious, but we know that in mathematics, except the axioms, we have to prove other things rigorously. Okay. So I don't want to review the content because everything is on the YouTube. So if you have forgotten something, you can go and watch the videos to refresh your memory. Okay. But let me just talk about the last thing we discussed, and that was, do you remember? It was the triangle inequality. So we learned that if you give me a triangle, any type of triangle, ABC, then, of course, if I call this length opposite to this by little a, this one little c, this one little b, we were able to prove, using this axiom, that a plus b is always greater than the third one. A plus c is also greater than the third one. B plus c is also greater than the third one. Yes? So if I add two of them, it is definitely greater than the length of the third one. Yes? That's called the triangle inequality. So the sum of the lengths of two sides of any triangle is always greater than the length of the third side. That is actually the content of this triangle inequality. And I actually modified this a little bit, and I told that, okay, what can I say about the difference of the lengths? And I will, for example, if I ask you compare A, for example, in the picture that I have drawn here for you, you see that the length of B is greater than the length of C. So if I subtract them, so what do you think will be the relation between the length A and this number B minus C? And of course, intuitively, it seems clear that A is greater than B minus C, but that is exactly the same thing here. So you see, if I move this to the other side of the inequality, so that's an algebraic property. So I can add minus C to both sides. Its effect is just moving C to the other side and changing the sign. So this becomes A greater than B minus C. Yes? So that's just a simple fact from here. And of course, if I use the other one, A plus B is also greater than C. This time I move B to the right, so this becomes A greater than C minus B. Now you see that A is both greater than B minus C and C minus B, so it means that if I want to make sure that none of these numbers are negative, I can immediately conclude that A is greater than the absolute value of the difference between these two. Yes, and absolute value means the magnitude of the number. So this means that now if I combine this with the third one here, I have a nicer one. I can write whatever A is, it's always less than B plus C, and it is always greater than the difference of these two. Yes? So a length lies one side, the length of one side lies between these two numbers, and then I can write the same thing for B. It is less than A plus C, but it is greater than A minus C absolute value, and C is less than A plus B, and it's greater than A minus B absolute value. So this is something I want you to have in mind when you are working with triangles. Okay. Now my question is, can I have a triangle whose sides are 1, 2, and 4 centimeters, for example? Can I construct a triangle whose sides are 1, 2, and 4 centimeters? Yes?
No.
Why?
Because 1 plus 2 is less than 4.
Okay, let me say, are you using the same theorem or we need an extra theorem for that?
It's the same theorem, right? It's that theorem, isn't it?
Yeah, I mean, that is the same theorem. I want you to understand that is the same theorem because, but you are thinking in that way that I want you to know this. Any if and then statement is always equivalent to its contrapositive, yes? This implication is called the contrapositive. Of this implication. And they are equivalent. And this symbol that I have used here means negation. For example, 2 is larger than 2 is less than 3 is a statement. In this case, this statement is true, yes? And its negation, if I say what is the negation of this, what's the negation of this? Yes?
3 is greater than 2.
No. The negation is that this is not the case that 2 is less than 3. Yes? But this is a very odd language, so we don't say like that. This means that this is not the case that 2 is less than 3, means that 2, if you want to, you can write this symbol. But this symbol doesn't mean that 2 is greater than 3 because there is another scenario, yes? So you should say that 2 is equal to 3 or 2 is greater than 3. Yes? So when you say that negation of this statement, I'm not saying that this is true or false, yes? Of course, if a statement is true, you expect that its negation is false. Yes, and of course the negation is false. But if I ask you to write the negation of this statement, you need to say that this is not the case that 2 is less than 3. It means that either 2 is equal to 3 or 2 is greater than 3. So you cannot make sure that this is definitely 2 is greater than 3. So that's something like this. When you have a negation, I mean this. And in mathematics, when you say if then Q, it is completely equivalent to saying that if not Q, then not P. Yes?
Can you make a negation of a true statement that is also true?
No. No. Yeah, the negation of a true statement is a false statement. And that's the definition of negation. A negation of a statement is another statement whose value is completely opposite to the value of the original statement.
So would a negation of a false statement be true?
Yes. The negation, the best. So if you want the table of values, I don't want to go through this. Might be at some point we go. If P is a statement, it has two values. A statement can be either true or false. But if the statement is true, negation of P is a statement defined by this table of value. Yes? Okay. So what you are saying, I just want you to understand this. I say that this is the same theorem. I would say that these two theorems are the same. But I told you that P, if P then Q, and if Q then P, they are not the same theorems. Even if one of them is true, there is no guarantee that the other one is true. If you want, you have to check it out. Yes? So they might not be equivalent, but they are equivalent. When they are equivalent, I would say that these two are the same, more or less. Yes, that's probably a little bit of sloppy language, but that's what I'm saying. Now, what I asked you, you said that this is the same theorem, and I agree with you, because that's the contrapositive of that, yes? So you say that, so I would say that if A, B, C are lengths of a triangle, then I should have A plus B greater than C and, this is and, A plus C greater than B and B plus C greater than A. Yes? So this is your P statement. this is your Q statement. Yes? So if this happens, then this happens. Yes? That is if and then. So that is any theorem that we have is if this, then that. Yes? Okay, but now this theorem, whenever you have P, if P then Q, remember, it is equivalent to its contrapositive. It means that you negate each of them and change the order. So that is called the converse. Do you remember? I told you that this is called the converse. The converse of this implication. Yes? Okay, but the converse might be true, might be false. But the contrapositive is equivalent to the theorem itself. So what is the contrapositive? Can you read it now? So if P then Q, its contrapositive means that I have to negate this and say that then negation of that. Yes?
I mean, if A plus B is not, A plus B is not greater than C, and so on.
No, not and so on. Be careful. Yes?
Can we say it should be A plus B should be less than or equal to C, or A plus...
Or. That's what I was emphasizing. And changes to or. Yes? That's the crucial point. So you say that if this, then this, it's contrapositive. The negation of Q, the negation of and, is actually, that's called Demorgan Law. If I have P, I will not talk about these things right now, but I want you to understand. If I want to negate and, yes, this becomes negation of P or negation of Q. Yes, these are called the Demorgan Laws, yes. Yes, and if I have the negation of P or Q, can you predict what it will be?
Negation of Q and P.
Negation of P and negation of Q, yes. So what you are saying is that if this is not the case, if not Q means, not Q in this case means A plus B is less than or equal to C, or A plus C is less or equal to B, or B plus C is less than or equal to A, yes? This is the negation of Q. If one of these happens, then negation of P. Negation of P tells me this is not the case that A, B, C are lengths of a triangle. Is that understandable? So it tells you that if at least one of these happen, I can conclude that A, B, and C cannot be the lengths of a triangle. So as I asked Oscar, actually, you tell me that this is the same theorem and you are right. That is not the same, it is the contrapositive of the same theorem. Yes, is that understandable? But I would say that's the same theorem. I don't need to prove something more to conclude that. So if I give you these, is there any triangle with these numbers as sides? The answer is no. Because, for example, 1 plus 2 is not larger than 4. Because of that, I can conclude that no, I cannot construct a triangle like this. Okay, what about the other way around? Do you think the converse of this theorem is also true? Now, the converse is something different. And I hope that you understand at this level that whenever I prove something, there is no guarantee that its converse is true. I have to check it out. Okay, so how do you read the converse? The converse, you just change the Q and P. So how do you read it? Yes?
If A plus B is greater than C and
Yes.
everyone else, then A, B, C are lengths of a triangle.
Yes. Okay, but do you think this is true or false?
Probably true.
Okay, so I agree with you, but do you have any idea how we can convince ourselves at least that this is true? If I give you 3 numbers, so that these 3 numbers satisfy all these 3 conditions, because there is and between them, yes? Can I conclude that yes, these numbers, then I can construct a triangle with those numbers as sides? Might be we need more axioms, I don't know, but intuitively, for example, can I construct a triangle? So you see, when you want to say no, you don't need a new theorem. If it doesn't work, that is the contrapositive of the same theorem. But if you want to say yes, if I give you, for example, numbers, can you tell me 3, 4, and what? For example, 6. 3, 4, and 6. Do you think I can make a triangle whose sides are 3 centimeters, 4 centimeters, and 6 centimeters? Can I do that or not? Do I need a new theorem or not? Do I need a new theorem, or this is the same theorem?
It's
Right? No. Or do we?
This is not the same theorem, yes?
What?
Yeah, we're
Do you agree with me? Because you want to say yes. This theorem tells you that if you have your triangle, these conditions are satisfied. It doesn't tell you that if these conditions are satisfied, you are not guaranteed to have a triangle. Yes, this is not the case. So here, if I give you 3, 4, and 6, I cannot say that, okay, Babak, you have proven that if I have a triangle, those conditions are satisfied. What I need, I can check these numbers. 3 plus 4 is greater than 6. Is it true or false? It's true. 3 plus 6 greater than 4. True or false? True. And then 6 plus 4 greater than 3. True or false? True. Yes? I just want you to know that I checked all these inequalities. All of them are true. And I want to conclude that yes, I can construct a triangle with these numbers as lengths. Is this the same theorem or not?
No.
No. Is that understandable? Because this theorem tells you that if you have your triangles, these inequalities are guaranteed. It doesn't tell you that if these inequalities are guaranteed, you have your triangle. Yes, I want you to feel, this is a very crucial part I want you to understand. So this means that I have to rethink again. This might be true or might be false. But can you just constructively convince me that this is true?
Yeah, if we assume that this is the case, that all these statements can be true, but or that Q is true but P is false.
Yes.
Which is what we're worrying about right now. If we assume that is a possibility, that means that Q can be true while P is false.
Yes.
But shouldn't that go against our theorem? Because haven't we said?
No, it doesn't go. I just want you to feel. There is no way you can play around with these things.
Okay.
Yes. So if you want to go to Q, then P, you have to start a new line of argument all over again.
No shortcut.
Might be do you remember we had something like this before? Do you remember I told you that if I have a triangle, so that one angle is a smaller, so one side is longer than the other side, we were able to prove that this angle is also larger than that angle. And then I told you the converse is also true. And in the converse, I use this theorem again as a fact. That is true. But the way that I proved it was different from the way that I proved it here. Yes? So what I'm saying is that you need to think about these statements as pure logical statements. Just that, okay, I have one theorem, I don't have any proof right now. I don't know if you can prove it or right, but I hope that you can convince me constructively that this is always the case, and might be in our constructions we are using some intuitions, need some axioms that I really don't know right now. I haven't thought about it very deeply. But can you convince me I can do that constructively by saying that, okay, let us start making this triangle. How do you do that? Yes, do you want to say something?
No, I guess if we could try, it might be easier. If we could try to make a triangle which does fulfill these conditions, but try to find 3 numbers who fill those conditions but don't make a triangle.
That is how you want to do that.
Yeah, that's proof. Is that proof by contradiction?
No. Yes. So yeah, that's what I'm saying. You want to prove the same statement by proof by contradiction, which I don't know how.
Okay.
And what I'm saying is that try to convince me that we can construct this. Assume that you are an engineer, not a pure mathematician. and you really want to construct a triangle, you say that I cannot? Yes?
You can just draw 3 lines with those 3 different lengths. And
No, it's not that easy. Just if I draw the lines with these lengths and try to glue them, yes? But you need to make it constructively possible. So, what are the ancient tools in the hand of a geometer?
If we begin by drawing one of these sides.
Exactly. So this is practical. So it means that, for example, I can take my ruler, for example. I can draw a line any way that I like. For example, which one do you prefer? For example, 6. Yes?
Okay, sure.
The greater one. So I take my ruler. So this is the ancient tools in the hand of a geometer. The ruler and the compass, yes? So, okay.
And
So this is 6 centimeters, for example.
Mhm.
Okay, then what do you do?
And then we could imagine like attaching the other 2 sides to the 2 vertices or endpoints, but imagining having just attached one of the points of the line and still being able to rotate it around. So
Exactly. Okay, so practically tell me exactly what to do. Very simple. I have you have access to the compass, for
yeah,
example.
and then we can draw a circle around each of the points.
Exactly. So you put the needle of the compass here, yes, and open it up to 3 centimeters, yes, and then you draw, I don't know, a circle. Let me make it a little bit smaller. So this is not to scale, of course. It is hard to draw them, but this should be half of this. That is bad. Now that's a bad picture here. So you just draw this, but with 3 centimeters as its radius, yes? And then what do? You go and take the needle of the compass and put it here, and this time open it 4 centimeters, yes? And draw another circle. So, what happens for these 2 circles? If that condition holds, yes, a 3 plus 4 is greater than 6. So this radius is 3, the other radius is 4, and we know that 3 plus 4 is greater than 6. Then what happens for these 2 circles? Yes?
they will overlap.
They will intersect. Yes? And then if they intersect, this point lies on this circle, so its distance to its middle point, to its center, is 3. And then if I connect this one to that one, it is 4. Yes? Because that is the radius of that one. So you see that for going back, one of them is enough. I don't need to check all of them. If one of them is true, probably I can construct, yes, or can't.
Yes, so
Because as I see now in the picture, I draw the longer one, but by the way, I started with the longer one. I put the longer one here, and then I draw the circles with these radii, yes? And then because 3 plus 4 is definitely larger than 6, there is no way that these 2 doesn't overlap.
yeah, so yes,
then-
one should be enough then.
Okay, so but I started with the larger one, yes?
What's the circle called? Is there a name for that circle?
Yeah, no.
I don't know the names of these circles here.
Well, is it like is there a name for like? There's no name for like the area of this.
No, I don't think this is there is a name for this circle, but there is a name for the circle that passes through the
Yeah,
vertices.
I guess we could have, if we start with one of the smaller sides,
Mhm.
which maybe is something, it could be, let's say 4,
Mhm.
and then one of the sides something pretty small like 2,
Mm-hmm.
and then this last side is like something very big like 10, so
Yeah.
that it like encompasses the
Exactly.
entire
Exactly.
smaller circle.
So it means that we have to guarantee
We have a
that
problem.
so we have to. But what I'm saying is that if I have only one of these inequalities, if I know that A is less than the sum of these 2 and larger than the subtraction of these 2, is that enough then? Because as you see, our construction strategy is really based on these 2 circles intersecting. If they don't intersect, then I will not have a point to connect to these vertices, yes? And as actually Rasmus said, is that it might be the difference is so small that these 2 circles, so if the distance is so large, these 2 circles do not overlap at all, do not intersect. Of course, if it is getting a little bit close, then these two circles will actually intersect. But if it is more close, then what will happen might be one of them go inside the other, and then still I do not have any intersection. Okay, so hopefully I hope that you agree with me that we also can go back, but by constructive way of thinking, yes, which is different from a mathematical argument. And I want to say you algebraically, one of them is equivalent to three of them. This double inequality is equivalent to all three of them. And that is easy because one of them you see in front of your eyes, and then this means b minus c is less than a, which means b is less than a plus c. And then you say that, okay, if absolute value is smaller than 1, definitely c minus b is also less than a, then it means that c is less than a plus b. Okay? Okay, but let me now forget about these very abstract things and then try to solve some nice problems together.
So wait, what was our conclusion?
Yes. So I mean that if you just check this one, it is like that you have checked all three of them.
Yeah, but did we conclude something about proving the converse, or when we can say?
Yes, we did. That's
No, I mean that, no, you see, let me see. What I'm saying is that if you check only this double inequality, it is equivalent to all three of them.
Yeah, but
And based on this constructive method, if I have all three of them, I can construct a triangle. So that's the converse.
Did we say that?
Pardon?
Did we say that?
Yes?
this method did prove that that one is true.
Well, yeah, but we also showed like some possibilities where this didn't work, our way of constructing.
No, it works.
Or
It works if I check both of them.
okay,
What
did not.
what didn't work?
Well, I did not understand where we drew the conclusion from that if all three are true, then we can construct this triangle.
So because if all of them, so you can say like this, if all of them are true, at least this one where this bigger one is on the right hand side is also true. Yes?
Yeah.
Yes? If all of them are true, it means the first one is also true.
Yeah.
And the method that we used is the case where we started with the larger one and drew these circles with these radii.
Oh, so we could also just say that if the larger side is smaller than the
that because the other one is actually automatically true.
yeah.
If the smaller ones, if the sum of the smaller ones is larger than the bigger one, the other two are automatically satisfied, aren't they? Yes. Isn't it clear? Yeah, it's not, it might be, I understand you. You can just write it down and convince you, it's not hard. Because the other two, this bigger one is on the left. This bigger one, on its own, is larger than any other two. It's easy.
Automatically. Just be.
I mean that if you have the larger one here, the smaller ones here, this you need to conserve. But if you have the larger one on the left, regardless of you have something else, it is already larger than the other.
I get it now. Yeah, of
Yeah,
course.
is that understandable? Yeah. Okay, now let us solve some problems together. I really enjoyed this problem when I was at your age when I saw it first time. It's very simple, but I would say it's elegant. So I would say that I have any triangle that you like, ABC, and then I take the middle point here, call it M, and I join A to M. What is the name of this one? I want you to know. What's the name?
Median.
Median. Yes, it's a median. I want you to show that this median is smaller, strictly smaller than the average of corresponding sides. So I want you to show that AM is less than the average of those sides. By the way, it's not that trivial. I don't know, could you guess something like that?
Yeah, I mean, it seems reasonable.
Yeah? Okay, I want you to think a little bit. I will pause recording video because that's a nice, simple problem. I want you to prove it. Okay, here, because my goal is to guide you, let me, for example, can you tell me what are you doing? Probably this is an example related to the triangle inequality. Because I remember I had this feeling that I started writing this triangle inequality in where you have to be a little bit reasonable, yes? So what do you think I can write? Because you know that what I'm supposed to prove, I'm supposed to prove this one, and if you multiply this in your head by 2, you see that on the left-hand side you have 2 times AM.
Mm-hmm.
And then you have 2 triangles crying out, use me, yes? Okay, so how can I use them? So can you tell me what should I do, for example? Tell me something, yes?
I mean,
It is probably not the first one. Because I want you to see what is the natural way of thinking usually, and sometimes the natural way of thinking doesn't work. Okay, so can you tell me, Oscar, what is your suggestion, for example?
well, I just wrote down like AB plus BC is less than AC, and well, my goal is to.
So, for example, so
Try to
if you started with a bigger triangle.
Yes.
Okay, this is my way of thinking. I would say that, okay, if I want to prove this, in my head I multiply it by 2, and I get 2am less than 8. So I go to a scratch work paper. So I would say 2am is less than AB plus AC. Then it motivates me, I need 2am's somewhere. Okay?
Great.
And then I see that there are 2 triangles involved somehow with AM. Yes? So what are those triangles?
ABM and AMC.
ABM and AMC. Okay, I will try to write inequality, the triangle inequality, and I try to respect this direction of this inequality. This is a smaller than 1, so smaller. So I would write AM, for example, is a smaller than what? Do you buy it or not? Is it true or false? This is definitely true in this triangle.
Mm-hmm.
Yes? And then, what do you think I will do?
Same thing for the other one.
Same thing with that one. It's reasonable. I want you to feel that. So this becomes AM is less than what? Can you tell me? What? In the other, it's AC plus MC or CM. Yes? And then it feels natural to add them side by side. Yes, you can do that. I can add AM to AM.
Oh, and they're equal.
Plus AM is less than AB plus BM plus AC plus CM. Agree with me or not?
Yeah. And
But then what happens?
BM and B.
Don't be in a hurry. This becomes 2AM, which is good. I need it. What happens? What do you think I can write for the right-hand side?
BM and CM.
Okay, BM and CM can be combined. BM and MC becomes what?
BC.
BC. So this becomes AB plus AC plus BC. Okay? And that's unfortunate. I cannot get rid of BC. Yes, is that understandable? So that was the way that I remember when I was at your age. That was my first attempt to do it. I was so happy that I solved it, but I realized that this is not done. So what you have proven here is completely true. Okay? Because if I divide by 2, I get AB plus AC plus BC divided by 2. Yes? I can write it in that way. AM is AB plus AC. In math in Olympiad problems, you have to be very quick in understanding these things. Okay? I was able to show that. If you tell me, is this true? I would say definitely it is true. But is it strong enough to prove what I need? No. Because I have shown this one is smaller than this one plus something positive. So I cannot conclude that this is definitely smaller than this part. This is smaller than the sum of these two, but there is no guarantee that this is smaller than that one. Okay? So, what is this one, by the way? This is called the perimeter. So I showed that this median is smaller than half of the perimeter of the triangle, okay? But I can do much better than that. Which inequality is stronger? This is a word that I use. What do I mean? If P implies Q, we say that P is stronger. Okay? So this is a stronger inequality, because if this were true, or if this is true, then I can also conclude this. Yes? But not the other way around. So I would say this is a stronger inequality. So I was able to prove a weaker inequality, but not the stronger one. I want you to feel these things that I'm telling you, and understandable. Okay? So then what? So you see, it was reasonable to think in that way, because I wanted to have two AMs, and I tried to use one triangle inequality in the other. Okay, because these are simple problems, I don't want to spend so much time on it. I want to give you a guide and then wait for you again, okay? So this trick, the people who are doing in Mathematics Olympiad, remember these tricks. You need to take notes to remember these tricks, okay? The trick here in this problem, which is very nice, where is my... So, if you don't mind, let me clean this one, even though it was very nice and logical, but we get disappointed. And this is always true with inequalities. When you think that the problem is solved, you cannot solve it, yes? I don't know why. This is why always they have some questions regarding, not always, most of the time, they have questions regarding proving inequalities, either algebraically or geometrically in Mathematics Olympiad questions, yes? So, I give you a hint. Extend the median to its own length again from this side and connect it to one of the vertices. So this trick, remember this trick. Whenever you are dealing with median, one possible way of thinking is this. So what I want to do, I want to extend this median from this side so that I am sure that AM is equal to A, if you don't mind, let me call it A prime. And then join it either to C or B, it doesn't matter. So in this picture, let me join it to C. And in the proof, in the exam proof, you have to explain these things in words. So you should say that I extend the median AM from M side point of view from this direction. So and then I continue it to get A prime, so that A prime M is equal to AM. And then I join A prime to C. So you have to explain a little bit of English sentence or Swedish sentence to this one, okay? And then see that how this will help you to solve the problem. I want to pause recording again. Okay, any ideas? Because I want to go forward, otherwise we will not be able to finish. Of course, I know that you have to also practice yourself. I will try to make some questions for you, make them ready. But the point that Oscar mentioned is correct. You need to compare these two triangles for the time being. Yes? These two triangles are congruent. But why? Because of SAS axiom. Why is that? Let us check. You can write this that BM is equal to MC. Do you agree with me here or not?
Yes.
Because that's the definition of the median, so it means M is the middle point. Exactly. So that is true. According to these two angles, let me call them M sub 1, M sub 2. They are also equal. Why? They are vertical. They are opposite angles, yes? So M1 is equal to M2. Everyone agrees? Yes? These are vertical angles. We had this before. And then I can say that AM is also equal to MA prime. Do you agree with this one? That is the way that I constructed it myself. Yes? And now can you see that? So let me just highlight them. These two are the same. These two are the same. and the angles between these two sides. So that's exactly side, angle, side. Angle is between two sides. That's the side, angle, side axiom. I can conclude that triangle ABM is congruent to which triangle? A prime. If you want to keep the order, I don't need to be worried about this, but in principle you have to keep the order. So A corresponds to A prime, and then B corresponds to what? C, and then M to M. Yes? Okay, and then what can you conclude then? What is the point? You can conclude any part of this triangle is equal to that corresponding part of this triangle. Might be I don't need all of them, I need one of them. What is that one, Oscar?
What part do we need?
So I mean that what I can conclude different things, but what do I need here?
Well, I mean, a prime is
AB is equal to
exactly it's equal to
A prime
C.
C.
Exactly.
Yes? Understandable. Now change your perspective to a different triangle. Yes? Change your perspective here to this bigger triangle. Yes? That is one triangle at the end. And then we know that we can use the triangle inequality. So you should say that in triangle A prime, C, what can I write? I can write that A prime is less than A prime C plus AC. That's the triangle inequality, yes? In this triangle, this length is the length of one side is smaller than the sum of the lengths of the other sides, yes? But what can I write instead of AA prime?
2AM.
2AM, yes? So instead of AA prime, I write 2AM less than, instead of A prime C, I can put AB. Instead of AC, I just write AC. And then I divide by 2. So I really enjoyed this problem when I was actually 14 or something. So, yes, even though I acted reasonably correct in the first procedure, but I was not able to find this stronger inequality. And that is it. I really want you to memorize that. In any triangle, the median of each side is actually strictly smaller than the average of the other two sides. Is that clear? Yes? Okay, now let us make it a little bit, so you see that whenever you think this is very, so it was not that trivial, you know? And this trick, whenever you have some problems with medians, remember extension, something like that in your mind. You have to solve a lot of problems and then try to somehow remember them so that you increase your chances to solve a new problem harder. Okay. Okay, if I ask you this question, this question I think is simple and you can solve it. So, if I take a triangle ABC, any one that you like, I choose a random point interior to my triangle and I call it O. Yes? And then I start connecting it to the vertices. Yes? I want you to show that OA plus OB plus OC is less than the perimeter of this triangle. And the perimeter is denoted by 2S. It's a little bit a strange way. I have seen 2P and 2S. Older books, they use 2P, but I think this is more standard now. So when I say 2S, so S is not the parameter, is half of the parameter. Yes? So remember, S, I will use S. So I want to show that this is a standard in geometry. When you see 2S in a text with little s, it means that with bigger S, it means area. With little s, it means that half of the parameter. And the reason that we define the 2 here, because we want to make more some other theorems look nice. Otherwise, this 2 will actually makes it ugly.
Where does this S come from? Or like, why is it called S?
I don't know exactly.
Okay.
Because that's why P was more sensible. When I was actually studying geometry, I learned it is called 2P.
So,
Which is 2 times, even 2P is not good because this is not parameter, it's 2 times the parameter. P is half of the parameter.
okay, yes. Okay, so 2S and 2P is the entire parameter.
Yes.
Okay.
Yes. This is simple. I'm completely sure that you can solve it. Yes, wait. Yeah, that's correct. That's correct. Because one of them is hard. Let me see which one is which. Yeah, that's correct. This is true, but unfortunately I started with the harder one.
Great.
I wanted to tell you, prove this is greater than that one. So now you know the secret. That is true. So this is the general one that I want you to prove, but unfortunately, I wanted to tell you this one first, which is simpler to prove, and I told you the harder one. Okay? So this inequality I want you to remember again. If you want to do competitions, it's good to remember these things. Okay, so if I take a random point interior to the triangle and I join it to the 3 vertices and add these 3 line segments, the length of them, it's always smaller than the total perimeter, but it is always greater than half of the perimeter. This one was easier. I was supposed to give you this one first and then that one that is harder. Now, you see that something seems very easy, but it is hard sometimes. This is not that easy to prove. Okay, I want to discuss a little bit about that. But if you don't mind, let us forget about this. I will solve it today, but let us try to solve this one and convince ourselves that OA plus OB plus OC is larger than S. S is half of the parameter, yes? Okay, how can I prove this? I think your proof is correct for this one.
Yeah.
Yes?
Okay.
Okay, but I want to ask your ideas of others. What are your ideas about this? So if you have this, you have to go to a scratch paper and see what is S. What is S? S is half of the perimeter of this triangle. And what is the perimeter? Is AB plus AC plus BC divided by 2. Yes? So your goal is to prove this. Your goal is to show that this is greater than this number. Okay? How can I do that? So I need to use triangle inequality in a way that it is involved with OA, OB, OC, and somehow these things. And then how many triangles are there immediately? 3 of them you can work with. Yes, here is one narrow triangle. Here is another one. And then here you have another one. Yes? So let us test. There is no guarantee that you can solve the problem, especially in competition problems. The first the first attempt, more or less, it is wrong. Because otherwise the problem is straightforward and will not be entitled to be in the exam. Okay, so how can I prove this? Let us just test some ideas. So, for example, first of all, I see that I have written it in a greater than in this case. So I would say that in triangle OAB, what can I write? Do you agree if I write OA plus OB is greater than AB? Do you agree with that? This is the triangle inequality. But then what I have OAC. It is OA plus OC is greater than AC. And then I can similarly write another triangle inequality in this triangle. So OB plus OC is larger than ABC. Yes? Are they clear? And then you have a little bit of experience now. You can add the inequalities side by side. So on the right hand side, I will have AB plus AC plus BC. On the left-hand side, how many OAs you see? 2. So it becomes 2 OA. How many OBs you see? 2. And how many OCs you see? 2 again, yes? But what is this one? It is called 2S. Okay? And I divide everything by 2. So OA plus OB plus OC is greater than S. That's a good and simple fact. Yes? But the harder one, even though it seems more obvious, but it is harder to prove, yes? How do you look at it, into this problem? You want to prove that OA plus OB plus OS is really smaller than the whole perimeter, which seems very obvious, isn't it?
Yeah.
Yeah.
But we want to prove it.
It's not a complete proof, but maybe a strategy would be if we can prove that OC should be smaller than BC and that OA should be is smaller than AC and that OB is smaller than AB. So if we like pair if we pair up all the O lines with all the perimeter lines, if we can then individually prove that each one should be that the individual O lines should
I
be
don't
smaller
think
than
individually is a good idea, but you are actually, your strategy is correct.
Or
You are
if-
breaking down the problem.
or at least if you know that, then we can easily prove that the sum for the entire perimeter should be smaller than the interior, or no, that interior sum of all the interior lines should be smaller than the sum of all the outer lines or perimeter lines.
But your ideas using these words are correct.
But I don't know anything, or haven't gotten any further than that.
Okay, so this is strategy I want you to learn. Sometimes in inequalities, you can break down the problem into smaller pieces of what you said was correct. But I will consider pairs rather than individual lengths.
Oh yeah, that was what I meant, like, or...
Oh, okay, might be that's good. So what I'm trying to prove here is that if I have this scenario, don't get distracted. You can make the problem a little bit simpler for yourself by excluding OA from your investigation for the time being, yes? And consider only these two, yes? I consider, so for example, let O be here. That is supposed to be the same picture. I cannot just copy it exactly, but this is what I mean. Yes? I make the problem a little bit simpler myself. I don't consider OA for the time being. And as you mentioned, I go to a scratch paper. I myself ask, is it possible for me to show that OB plus OC is smaller than this one, AB plus AC? Because if this is true, hopefully you agree with me, I can use the same line of argument with another pair, and then add them up. Yes? Okay, so the point is that forget about that problem momentarily and try to convince me, even though it is very trivial and obvious, but we have to prove it. We have to show that OB plus OC is smaller than AB plus AC. How do you do that?
You have to show that.
This, I remember I had a hard time to prove this when I was at your age, okay? So, because I was trying to work with inequalities and everything. I will pause recording the video, and I want you to think about this very sensible fact that OB, if O is inside the triangle, OB plus OC should be smaller than AB plus AC. But why? If you couldn't, then I give you a hint and I wait for you again. This is the nature of this class. You have to train your brain to think and solve harder problems. Any progress? Okay, just talk to me. What is the what? How are you thinking?
No, I'm thinking that
Because I was able to do something right, but I couldn't finalize it.
like,
So what are you doing? I think. Yeah, just tell me. I don't want to give you a hint. What are you thinking about?
well, I'm thinking BC is in common, so I'm trying to use that in some way.
That is probably not working. Yes. Okay. BC is in common. Then what?
I don't know.
Okay. So if you don't know, you need to change the strategy. If it doesn't work, you need to train yourself for this kind of thing because you haven't. In the best scenario, you have 1 hour and a half for one problem. So and the problems are really hard. So you have to learn. If an idea doesn't work, just let it go. And try ideas, one idea after another. Okay, so another idea. Okay, just tell me.
Like any move, if we imagine like the line AO, and or like the line that passes through A and O,
Mhm.
and we imagine that O like lies somewhere in this line, somewhere between A and further down, then I guess it's maybe too intuitive, but it does make sense that both for any like movement downwards or further away from A, OB and OC should get smaller and smaller until
No, that's
we,
the same problem essentially.
yeah,
Because you are saying that okay, if I bring it down, it is smaller. It's essentially the same problem. So it doesn't work like that. And don't bring OA into the problem. If you trust me, just work without OA now. But okay, BC didn't work. OA idea didn't work. Any other idea? Come on. How many triangles you see? 2.
Yeah.
2 is not enough. You need more. So then,
Need more triangles.
like then the only triangle I can think of uses AO. And
okay, you go back to the same strategy again.
And we weren't supposed to use.
No, you are not supposed. You might find a way that uses OA. I am trying to describe my way for you. Okay. I'm not. I cannot say that. Okay, your method is wrong unless you can write it and defend it yourself. But I'm trying to say that if you really forget about OA momentarily,
Yeah.
if you
Do like the last time you make the triangle under.
under that one,
Yeah.
so that might be the case, but simpler. Do the simple ideas first. So if you want to make it under, what do you mean under? You want to flip it exactly like that? Because you cannot say under that. I cannot draw a random actually triangle below. Yes.
I mean, that won't be helpful.
Okay, let me give you a hint. Yes. I don't know. It was. I would extend this. And then, for example, let us call it X. Let me call it D, okay? So, I don't know. I extend this so that it intersects AC at point D. Then I have 1, 2, 3 triangles. So I increase the number of triangles. Might be it doesn't work, I don't know. And I remember I was able to extend that, but I was not able to finalize the problem. I don't remember why, because now it seems very obvious for me, but I couldn't do that. Now I want to wait for you again. But you need, by the way, be careful, you have to write this on the exam. Okay? Whatever you add, you have to write. I want to wait for you again.
I mean, because like BOC is a part of BAC, and like you can clearly see that there's like 2 extra triangles with their own values. So it's like, I mean, it just feels.
If you say BO is smaller than BD, I agree with you because that's a part of BD.
Yeah.
Okay, then what? Because our approach is not that precise. Yes, you are right. If I say BO is smaller than BD, I agree with you.
If I can show, like with this, if you could show that BOC is smaller than BAC, I mean, is that? Like,
Well, that's the same thing we want to do, actually.
Yeah.
Yes.
True, except for the reason when you say vi har ju 205 då. Som existerar.
Okay, let me try to see how it goes. You see, in a scratch paper, this is my goal. Okay, so I have to be able to compare OB and OC somehow with AB and AC, but I will not be able to do it individually, so I need to construct this sum somehow. Okay, so how do you think? Just try to, by the way, sometimes you have to do trial and error, so it means that you have to write inequalities, add them, subtract them. If it doesn't work, then just throw them away and do the other thing. That's the whole fun part of this, yes? So, what do you think I can do here? So you see, you want to have OB, OC, AB, and AC somehow involved, yes? For example, do you agree with this one? AB plus AD is larger than what? Can you tell me? AB plus AD is larger than
BD.
BD. Is that understandable? And that is good. You see, I don't know. So you see, I don't remember the method. I have to try to find it myself again. But I see that AB is on the right-hand side. If I flip it around, it means that I have to have AB plus AC is greater than OB plus OC. That's my goal, which is equivalent to this one. So this is why, this is a good guide. I put AB on the left. And I wrote AB plus AD is greater than BD. Okay. But somehow you want to have AC also involved. Yes? Okay, can you tell me what can I write now here? Okay.
Is it?
So because BD is good, because BD is not in my goal. OB is, but no problems. BD can be written as OB plus what? OD. Yes, it's good. So you see on the left hand side, this is the way that I think. I have AB, I need it. I have somehow OB, and I need it. Okay? This is a strategy. So then I need to somehow make it a way that I can find AC and OC in my missing relation. So then I concentrate on AC and OC.
So
Where is AC? AC is this longer one, and OC is this one. Okay, then what?
So OC is OC. Well, I guess OC plus OD is bigger than DC, maybe.
Bigger than?
DC.
Okay, so what you are saying is that, because if I write, no, because be careful, this is also good, not to try everything. I want to keep this sign like this. What you said, can you repeat it?
I just said DO plus OC.
DOD plus
OC is
OC
larger than DC.
is larger than DC. Okay, it's a little bit the other way around, because you see here in the way that you are solving it in that way, OC appears on the left. Yes? But in what you want to prove, OC should be somehow on the right. Of course, I can move it to the left, but it becomes negative. So then it means that forget about this, or at least the problem might be very harder, but this is probably not the way that you write. Yes, Hafsha?
DC plus OD is greater than OC.
That is more reasonable. Do you agree? Because now she's concentrating on this narrow triangle, yes? So, and saying that, can you repeat it again? OD plus
OD plus DC is
No, it's-
greater than OC.
OC. Yes? You see, I am following a strategy. So what Oscar said was not wrong, but it was a little bit against my strategy because this is a better one. Of course, that was the reason that I couldn't solve when I was at your age. I was finding this counterintuitive because I don't want OD, but that's the problem. If I add them, I have what I need. Yes? When I add them, the left-hand side becomes AB plus AD plus OD plus DC. What do I have on the right? I have OB plus OD plus OC. Agree? And this OD that I didn't like, that's not a problem for me because it also appears there. So I can cancel them out. And then OB, OC are exactly the ones that I need. And then I have to be lucky, and am I lucky or not? Because AD plus DC is what?
AC.
Is AC. So it was nice. When I was at your age, I couldn't see this. Okay? So this becomes AB plus AC is larger than OB plus OC. Is that understandable now? Yes or no?
Yes.
Okay, so this is the way that I wanted to do by extension. I didn't succeed. Then I realized that, okay, later this can be done. Yes? So you see, sometimes you need to broaden your perspective. But how can I use this to solve that problem now? More or less it is done. Do you agree?
Yeah.
Because, by the way, that's also completely acceptable in the exam. You can say, analogously, I can prove what? So I was able to prove that, OB plus OC is less than AB plus AC, yes? By cleaning this from my head, yes? And then you can write in the exam, analogously, what can you prove now, can you write?
Yeah.
OA plus
Let's see.
OC is less than AB plus BC, and analogously, you can prove this, and that's acceptable for this exam. So you can say that OA plus OB is less than what? AC plus BC. Agree? And then you add them up. So what happens? OA appears 2 times. OB appears 2 times. OC appears 2 times. On the left, each one of them appears 2 times again. Yeah? So it becomes 2AB, 2AC plus 2BC. And then I divide everything by 2 and I get this. And I want you to remember this. It's a good thing to remember. So OA plus OB plus OC is less than 2S but larger than S. Okay, now let me tell you something. I don't know, when I was at your age, I was not thinking to generalize this because at that time I didn't have that much experience. I don't know, I didn't find it in the articles that the people are generalizing this. That's a good thing. By the way, you can get a lot of ideas for your Gymnasiarbeit in this lesson. So you can just start getting interested in one of them and then try to start writing on it. And then when you are in the 3rd year, you have a lot of things that you can present, and then your Gymnasiarbeit work is actually done. Okay, so you really don't need to wait until the 3rd year to choose something. If you want to do it mathematically, if you want to do it something in mathematics, you can be inspired by the ideas that we have here. Okay. Let me ask you this question. I was taking this last night actually myself. If I have this scenario, instead of I have a triangle, for example, I have this. Okay, do you think the sum of all these is larger than the other one or not?
I would.
So for example, if this is A, this is B, this is C, this is D, this is E. Okay?
I would
Is A plus B plus C plus D plus E? Is greater than E.
Yes.
But why?
We could probably use the same proof as us, right?
So the reason that I got interested in this is that polygon line we were discussing, and by the way, I haven't solved that problem for you yet. I remember that. But why A plus B plus C plus D is larger than E? Why do you think it is?
Well, why? Well, we don't know why this is true for a triangle either, do we?
No, we do.
No, for triangle, we took this SAS as an axiom, and that's, yes, we proved that.
Can we use that?
Or if
In a triangle, we proved it, but by using SAS as an axiom.
Can we use that again?
Yes, you can use it, of course.
Can we just line up?
Yeah, but it is not hard. Yes, how do you prove it? Using the triangle inequality.
Well, I mean,
It's easy. So, for example, you can take this
okay,
one and
yeah.
join it here to make triangles. Yes, and join it here. And then let me call this an X. Let me call this one Y. Yes. Can I say that A plus B is greater than X?
yes.
Yes, in this triangle. Can I say, I don't know, C plus D is greater than Y? In that triangle. Do you agree with me?
Mm.
And then what do you think? I want to have A plus B plus C plus D, so it is motivating me to add them side by side. So it becomes A plus B plus C plus D is greater than X plus Y, yes? But now what happens for X plus Y?
Greater than E.
X plus Y in this middle triangle is greater than E, yes? So that is greater than E, so that is the way that I solved it yesterday. And then I was thinking, still it's an open problem for me. So here, what we showed is that if I have a triangle and I take something inside, the sum of these two is larger than the sum of these two. And we showed that here, yes? Now I was thinking, can we extend that? Then I had some problems. How we want to extend this? For example, first of all, I don't know the solution. I just want you to think about it yourself. We can discuss about that. So assume that instead of having 2 lines, let me have 3 lines. Yes? And inside that, I also have 3 lines. I don't know, for some reason I haven't seen these in the literature. Okay, now do you think the sum of these is also smaller than the sum of these?
Of course.
Wait, how?
I'm just thinking, I don't know. I just, before sleeping, I thought that why people doesn't talk about this. They don't talk about this. So, and then I realized I was thinking that might be, first of all, I was thinking that might be this should be true. That if I have this one, and it doesn't matter how many times I go, but then I realize it matters. Yes? So you see that you can make it much larger than that one. Is that understandable? Yes? So you can just go back and forth a lot so that it... So then I would say that, okay, let us have this restriction. If I have 3 line segments, let me restrict myself to 3 line segments inside that. So how can we prove that the sum of these green ones is smaller than the sum of those ones? And can we extend that problem to more? I just Google it in 1 or 2 minutes. I couldn't find a good result there. So yeah. I was thinking that that's also an interesting problem to think about, yes? And I want you to think about this one as well by the next time. And I want to give you one problem open. I know the solution. I want you to think about this. This is a very nice problem. Okay? So the problem is this. I have 2 lines. I have 1 line. Line goes to infinity. Let me clean that because we have only 2 minutes. I give you 1 point here. It's not on my line. I give you another point somewhere else, not on the line. The question is this. Tell me, where should I choose a point on L so that the sum of the distances from that point to A and B is minimum? The question is this. I have L, A, and B fixed, for example, in this structure. the point is that this goes to infinity from both sides, that's a line. My point is to choose a point so that, for example, M, if I connect it to A and if I connect it to B and consider the length MA plus MB, this becomes minimum. So you see that what is the meaning of becoming minimum? So you see immediately that if I take it here, then this length and that length are different. So I want to fine-tune the place of this M so that it guarantees that the sum of these two line segments is minimum, the minimum possible value. Is that understandable? Is that clear? Because you know that when I start changing M, I am changing these lengths. I don't care about individual lengths. I want to care about the sum of these two lengths. So if you take and measure this one and measure that one, I don't know, for example, if you go very, very far away, this is useless. I hope that you agree with me. Yes? I'm making it bigger and bigger. But I want you to understand this problem. It's a very, very nice problem. I want you to tell me, how can I find this point so that MA plus MB is smaller than any other choices for M? That's a good problem to solve, yes? And also I really want you to think, if you are interested in discovering something, you can also think about these problems. Can we make a theorem out of them? Yes, as actually, that was a nice experience that we had, I don't know, with Rasmus and Oskar. We actually did some progress on those broken lines and interior angles. So that's also good to think about this. Okay, thank you very much. See you next time.